So in this example, we have a satellite that's going to be put into circular orbit 250 kilometers above Earth's surface. We want to know how fast that satellite would have to travel, and then what would be the period and its radial acceleration. So we know from the last video that the velocity as the object goes around the Earth can be found by just knowing how far above the Earth it is, so the radius of the Earth plus the height above the Earth. And then we just need to know the mass of the Earth and the gravitational constant. Remember to convert everything to meters because that's important when you're dealing with the gravitational constant. If you're going to use 6.67 times 10 to the minus 11, you need to have the distance in meters. So the velocity of the satellite, 250 kilometers above the Earth, would have to be 7,756 meters per second. At the surface, it would have to be 8,000 meters per second. So here, we've determined that if you go just a little bit higher, that it need only be 7,700 meters per second. We can now use this to determine the period of that particular object. We know that the period is equal to the distance divided by the velocity, so the circumference of the orbit divided by the velocity at which it travels. And from that, determine that the period of this particular satellite would be 5,370 seconds, or 89.5 minutes, or about an hour and a half. And determine the radial acceleration, we just want to find v squared over r. We find the radial acceleration 9.074 meters per second squared. So we can use this process to solve for any satellite that's above Earth's surface, or to solve for any satellite orbiting any object. We just have to assume that it's a circle.